every time you look at the electric meter. Yep. Phase 2, we go call the electric company names.
I know, right? I'm telling you.
But the real thief is the consumption of all the items that we have hooked onto our system. You see, ZESCO's tariff is only applicable at purchase. Once the units are in your meter, the rest is on you and those people that you are keeping.
From camping tents to the massive industries, this is Power My Space.
Like we learned on the last episode, calculating the consumption of all the items hooked to your system and how long they are powered will help you roughly estimate how much you consume in a month. But then why are we talking about units on an alternative power show? Well, that is because the same thing that bites you when you buy your units is the same thing that will bite how long your battery lasts. So today, we get back to the basics. So take your pen, paper, because we're going to be doing a lot of writing. I'm ready. Pen, book. Somebody get this guy off my set. Can start.
Episode 2. What are batteries and inverters anyway?
Before we get started, let's look at how the grid actually works.
There are 3 things that are involved. You have to generate, that's the first part. Power will be generated at the hydro station where they generate it. And there is also what we call, you have to transmit that power.
For generated electricity to reach your home, even if you stay on the far end of the country, it is stepped up to 330 kV. That's nearly 1,375 times the power we receive in our homes.
So when you are transmitting voltage, we normally transmit it at the high voltage because we want to reduce on the losses on the transmission line.
This makes it possible for it to cover massive distances spanning across provinces until your home.
Then after that, there is a part which is called distribution. They will distribute according to the way we want to use. So the reason why we normally receive 230 volts at a domestic level, that is the standard. It's domestic level because we are not industrial users.
So when deciding to go off-grid, a few things are critical. Number 1, get your own Kariba dam. Alternative.
It is critical to decide from the very beginning what your alternative power source will be off-grid. Wind, fuel, biomass, small-scale hydro maybe. But in this episode, we focus on solar energy.
We have a few types of panels on the market. Some of them being the most common ones, especially on our markets, are monocrystalline solar panels, and we also have polycrystalline solar panels. With monocrystalline panels being the most efficient, having an efficiency between 18 and 25%, while the polycrystalline panels having an efficiency less than 18%. So we have to consult a technician before we try to choose which one we are going for.
When ordering solar panels, you may not always see the words solar panels. You may also see PV.
PV is photovoltaic, like the name implies. It means photo coming from light. So what this technology really is about is to draw energy from the light, from the sun, and then convert it into DC.
Number 2, skip the transformers.
If you have a DC source, use an inverter. The word inverter itself, in its most purest form, is just simply converting from DC to AC.
Because most of our appliances that we use are actually AC.
But wait, what is all this talk about AC and DC?
DC, when they say DC, it's a short form for direct current.
This current is mainly derived from batteries.
Or a solar panel.
It has polarities.
One directional,
Move from positive to negative.
and there's no phase shift.
You take into consideration to say this is the positive part, this is the negative part.
So the inverter then converts that DC power that is coming from the batteries or from the solar panels into AC.
We call it alternating current.
So we use AC in most of our appliances.
Electrical devices such as stoves, these are AC. Households, they have DC and AC devices.
Our batteries in our phones, those batteries in our vehicles, those are direct current devices. On a socket in a house, normally those are AC. You find that you don't care about the polarities. You can connect them anyhow. You find that you are able to get the power at the end user.
But these inverters seem to do more than just converting.
An inverter comes as a packaged good. So if we're going to talk about an inverter, it might have a transformer inside, where after the voltage is converted from DC to AC, then it goes into a transformer, then it gives us a 230 that we can use in our homes.
But you need to know the size of demand that you are trying to meet.
Let's take it you have calculated all the items in your home and have settled at roughly 4 kilowatts of consumption. When building your system, the first thing you consider is the size of your inverter, because the inverter will determine how many appliances you can connect to your system.
You have to look what is the usage. How do you want to use power? What is your purpose for the power that you are generating?
So for example, a TV would say will be 200 watts. Whatever that is the power that something uses for it to to be functional. So if your power in the house, the power consumption is say 2000 watts, then you need an inverter of at least 2000 watts plus. Okay, so you need to marry your consumption with what the inverter really can use, because the inverter is really the bottleneck. It's not unlimited power, rather.
Aha, the return of the calculator from last episode.
The inverter size determines every choice you make, including the size and number of panels, and also the size and number of batteries.
For a 10 kilowatt inverter, that's 10,000 watts. And if you're using 500 watt panels, then you know I need to use X amount. So it's simple calculations, and the manufacturer does actually help with the workings. They'll tell you this one you need X amount of power. So if you know that you need 7,000 watts, if you're using 650, you divide it to give you the number. If you're using 610 watts, you divide it to give you the number of panels that you need for this to work.
Number 3, maintain steady supply to avoid domestic load shedding.
Batteries come in different shapes and sizes, literally. Short and wide, tall and narrow.
So for lead acid batteries, they're much more dangerous to handle.
But is there such a thing as a better battery?
But what you want is just a quality brand that has support in terms of warranty, the battery that will actually do the job.
I would say the lithium-ion cells. Why? Because of the efficiency. They also have a better depth of discharge. They're also durable, and they're also already available on the market.
Alright, we have been spoiled for knowledge and we're excited. Life seems easy. Calculating watts is how you know the consumption. But then it's time to go and buy the battery. We don't seem to find what's written on the battery. We meet instead the amp hour. What is this anyway?
Two factors on the battery. One is going to be the amp hour. For example, this battery that we're looking at is 106 amp hour capacity, and it's a 51.2 volts. So 51.2 volts, and it's multiplied by the 106 amp hour, it will give you the total power that is stored in this particular battery, which works out to 5,427.
So if I understand these guys correctly, multiplying the volts of the battery by the amp hour will give me the watts equivalent. So my 12 volts by 200 amp hour is about 2,400 watts. So meaning if my load is only 400 watts, then I will get 6 hours out of the battery. Okay, seems fair enough. However, batteries are not really 100% efficient. So it is safer not to overestimate your batteries.
So those parameters, even when you see a battery, those parameters are calculated or determined at its maximum. That's when you are able to get that amount due to it having its maximum capacity at that point.
So let's just cancel that 6 hours. Just throw it in the bin. Give yourself 3 to 4 hours. So if I want more hours, I just add more batteries.
But with the buzz of going off-grid being a big deal now, a few things need to be taken note of. I'm sure you've seen it all over social media. These guys.
I think the first thing is poor workmanship. That's the number one thing. Unfortunately, when there was this rush of PV technology, everyone was rushing into this business without having adequate knowledge of doing it, and also prior training.
Environmental causes, technical causes such as wrong installation or wrong wiring of these panels. So for us to conclusively determine what caused the panels to burn, we have to be on site and see exactly what has been done.
That's just how we are. We try to do a shortcut, okay?
And these guys. What's going on here?
Lithium batteries are not supposed to go to zero. So you put certain parameters or certain settings to say the minimum threshold, to say at least it will go off when it gets 15%, and then you can increase, we can adjust.
Now I know we did promise that we're touching smart systems. Now let's talk about that a bit more.
Just like phones, it's the same technology. So a smart technology will have features like you are able to monitor it remotely. You know how it's functioning, how much power is being drawn, right? And how much power is being generated from the panels, the grid, or how much power is being stored in the grid, and actually change those parameters. For purposes of control, you know that what we have is a 12 kilowatt unit, 12 kilowatt system, and you see you're at work, for example, and everyone knows at home, for it to last long, do not load it up to, let's say you've said don't load it up to 3,000 or 4,000. So you check, so you see it's above 4,000, it's above what? Then you call people at home, or you can switch it off remotely, you can switch it on remotely, you can turn off the grid, you can turn it off, on and off remotely, and also change the parameters. And then not only that, the system and the battery are communicating to each other. So,
is there a way of combining them?
So it has to, obviously, there has to be compatibility. So when you look at these smart batteries, they'll actually say what technologies this battery or what technologies this inverter is compatible with. Unfortunately, Blue Sun is proprietary locked. Blue Sun Solar only works with Blue Sun Solar technology. But there are other inverters like there, I know it uses maybe 3 or 4 different technologies that are compatible. There has to be a compatibility. Unfortunately, you cannot use a non-smart battery on a smart inverter, because a smart inverter, for it to go on, there has to be communication with the battery.
Whew, what an academic run. I hope that pen and paper was put to good use, because those notes will come in handy even when you meet that guy who is burning those solar panels, and when you see those inverters that are going haywire, you will know what's happening. So next episode, we get practical. We are building our first ever system. Oh yes, we're getting our hands dirty. I hope not. But when we're done, we're turning it on for the very first time. And we're doing it together. Anybody? Please. That's it.